Hi, good evening, everyone. How are all of you? I am Mr. Chu here. All right, we are all here for uh the science open-ended question or structured questions. Okay, the new way to call it is called a structured questions. Okay, so have you had your dinner yet? Hi, hello. Now, great to see so many of you joining us today, right? Because it's a very important year and it's April, right? We are at the very right time to start getting our engine started, preparing for the PSLE. Okay, so great to see so many of you want us to improve on your science open-ended questions skills and techniques. Okay, now, so for today's session, if you have not downloaded the materials, please go and find. I hope you have the materials. Otherwise, I think you can download it from the link when you register. Okay. Right. So as I go through, all the things later, right? If you have questions, you want to ask questions, put your question in the Q&A. Okay. But please do not spam because as you can see, that's only me. Okay? It's just myself. All right. So if you spam, I cannot see your messages anyway. So I'll just try to answer as much as I can. All right. And hopefully all of you are obedient, right? Don't go and spam and don't write nonsense. Okay. What we want here today, right, is to have an effective lesson. Right. So let's help each other out. Right. Uh, Only give me responses that are useful, right, and help me move the lesson forward. Okay. Right. The link for the material can be found in the link in the chat. So if you have not downloaded that, yeah, please take a look at that. Right. So once again, thanks all of you for joining us, for joining me and my colleagues who are helping for the Zoom. Okay. Your butt is going to hurt. Now, this session is only 2 hours. Okay, it's not going to hurt so much. Oh, you can't download. Hmm. Okay, let me see. Let me try to click the link. Hmm. I can open the link and I see the file. So maybe you try again. Yeah. So I repeat again for those who have not gotten the file, the link is in the chat. Click it and download it. Okay, best of course if you have printed it so that you can write it physically. Right? Okay. Now, so without further ado, let me share my screen and we can begin. So it's very important, right, for all of you to start practicing on all this because all of you have just promoted from P5 and it's quite a big jump from P4 to P5. And P5 is when you just started getting used to it. But P6, all of you are already taking the PSLE. Okay, so you have to start now. So I'm glad that many of you have joined me today. Okay. Okay, you can only print if you have a printer at home, of course. Okay, so yeah, make sure your device is connected to a printer. No, okay, don't use the chat for fun. Okay, you're just chatting with me. So I need to see all your questions, okay, all the science questions. Right, so any science question put in the Q&A, yeah? So I'm seeing a lot of high and random things. So I need to, clear all this. Okay, so don't spam me. There's only myself to look at all these messages. Okay. All right. So let's get started. Now, what we are going through today is focusing on structured questions, or otherwise called the open-ended questions. Okay. Now, do take note, we have 3 sessions. Today is just the first one. So let me just bring that up. Where's that? You do not know the dates. Actually, it's all on the Thursday, this same timing. Okay, it's the same timing all on Thursdays. Okay, so basically 2 weeks late. I mean, every week for 3 consecutive weeks, we have this session. Okay, so you will see me 3 times. All right, so do take note of the dates. Basically, it's just next Thursday and the following Thursday, same time, 7:30 to 9:30. All right. All right, so our focus again is on structured questions. Why you want to focus on this? Because a lot of students tell me that, okay, you know the science concept, you understand the science concepts, but when you write the answers, you cannot write the correct answer. You don't get the full marks. Okay, so that's why we are focusing on this. But today's lesson is not on those questions which are topical, meaning that we are not dealing with questions in a particular topic. Okay, so what you want to look out for are the experiment-based questions. Okay, do you all know what is the weightage for experiment-based question in the PSLE? This one you can put in the chat. I just want to see how, you all know what's the weightage for experiment-based questions in the PSLE? A rough weightage in terms of percentage. Okay, some of you said 40%. Weightage means like out of 100%, how many percent do you think contains experiment-based question? Okay, I have a lot of answers. Thank you. So I see like 10, 20, 30, 40, 60, up to 60. Now, I'm talking about experiment-based questions. I'm not talking about structured questions or not the open-ended questions. So experiment-based questions, okay, if you do not know what experiment-based questions, that's what we'll be going through in these 3 lessons. Okay, but we have more than that. Okay, we have also some topical questions in the third session. Okay, but I'm not talking about the open-ended question. So I think some of you are confused. I'm talking about the experiment-based question, meaning that it's not just a recall and all. There's an experiment, there's an aim for the experiment, there's a conclusion, there's a relationship. Okay, so that is what we'll be going through today. Okay, it's definitely not 5%. Actually, it can test up to 30% of the whole paper. So meaning that you can master all the concepts well. You can you can fully master all the concepts for your syllabus. But if you can't do experiment-based questions, you cannot get your AR1. Okay? So this is very important. Now, even the highest weightage topic like electricity, maybe in 100 out of 100 marks, electricity is only 12 marks. But experiment-based question can go up to 30%, 30 marks. Okay? Across MCQ and structured questions. Okay, so it is very important for you to master this part here. Okay, but before we talk about the experiment-based questions, now we look at what we teach in my structure, our analysis and answering framework. Okay? So I'm going to teach you guys, all of you here, how to approach open-ended questions. Okay, how to approach that. So first thing, okay, basically we have this code method. Okay, but it's up to you whether you want to use this method. Basically, this is to guide you what you should do when you see a question. Okay, be MCQ or open-ended, this one will work. First thing, you must analyze the question. Analyze. In my structure, if I'm my structure students, okay, we actually teach 2 frameworks. First one is the question analysis framework. So we teach you how to analyze that. That is the CCC. Okay, so in this framework, let's scroll down to the part here. This is the next page. I'll go back there. I'll go back to the previous page later. So this is the CCC answering question analysis framework. So what you need to do is look at the question. What did the question ask you to do? We call that the command word, especially for structured questions. So structured question, we have some command words. Okay, we talk about that later. So that will give you instruction on what to do. Okay, then once you look at the question, you saw the command word, you should start thinking of what are the key concepts needed for the question. Okay, like for example, you see a picture of a flower, then it must most likely related to reproduction in plants or maybe adaptations. Okay, so start to bring your brain, towards that direction. Then, what is the context of the question? What are the information from the question that you can link together? Okay, and connect it to whatever concepts that you already know. So that's the context. Okay, so this is the CCC framework. So first thing is to analyze the whole question. Do not rush to go and answer the question. There's no point doing that. Okay, I know you all have very tight time, but you have very tight time. Okay, 1 hour 45 minutes to complete the PSLE paper. But if you rush to do everything, you miss out on some important things. You miss out on important keywords, and then there's a problem, right? You might get it wrong. Most likely you get it wrong. Now remember, you know how many marks each MCQ is? Yes, I'll talk about the command word later. Okay, each MCQ is 2 marks, correct? Okay, so anytime you make a careless mistake and you never check, never spot it, you lose 2 marks very quickly. Okay, and repeated careless mistake 2 times, 3 times, 4 times, you have lost maybe 10 marks already. And there goes the AR1. Okay, I have seen cases before. I have a student who I expect to, do very well because, during the regular practices, the student can score very high. But somehow, during the PSLE exam, did not get AR1. What could have happened? One possible reason is careless in MCQ. For some reason, you get quite a number of MCQ wrong, immediately you lost quite a bit of marks. Because each question uses 2 marks. You just need to get 5 MCQ wrong, you are down to AL2. So MCQ very important. You must get as high as possible and always check, choose the best option. Okay? So when you see the question, always try to underline or circle some keywords. Okay, when needed. Do not go and circle and underline every single thing. Then you can't see anything anymore. Okay, only those that you find that are really important. Okay, so don't jump to conclusion. Next one, organize your thoughts. So you have read through the whole question, roughly know what the question wants. You know the concept, you know what the question is talking about, the context, and you know what's the command word, what they want you to do. So then you start thinking, what are the things that you need? What are the concepts you need? Okay, do not just jump to conclusion. Don't look at one diagram, see one label. It says, okay, there was this PSLE question. Okay, I went through that during one of our webinar sharing session as well. Dust-like particles. In the question, it says dust-like particles. Okay, and what they ask for a characteristic of the plant. Okay, or whatever is happening in the picture. So a lot of students jump to conclusion, okay, thinking that these dust-like particles are spores. Because spores are usually very tiny, so they are kind of like dust-like, very, very small. But what was in the diagram for the PSLE question? It was a flower. My beautiful flower. It was a flower in the diagram. Although the question says it was dust-like, there were dust-like particles or dust-like substances. Okay, and many students think that they are spore. But these dust-like particles are actually seeds. They are extremely tiny. Not pollen, not pollen. Okay, so they are seeds. So that's where students just jump to conclusion, and a lot of students got that question wrong. Okay, if you have seen the PSLE question, you will know what I'm talking about. Okay, maybe later if I got time, I'll share with you that picture. All right, so don't jump to conclusion. Always find evidence in the question. Okay, now next one. So if it's open-ended question or structured questions, then next thing, you want to know how to write your answer. Okay, so in my tutorial, we teach this answering framework called the AIR. Okay, so this AIR is very similar to many of you, very similar to CER that you learn in school. I think most of you learn CER in school, okay, or you learn something similar. Okay, so in my tutorial, we call it AIR. We have it in our AIR component. So let me briefly talk about this AIR. Okay, maybe I talk about that later. Okay, so I go through in order. Okay, so I talk about answering framework later. So for some of these questions, you answer using a certain structure. But this framework, this CER, AIR framework, they cannot be applied to all questions. Okay, so most importantly is make sure your answers have some key terms, keywords. Whenever you need to compare, you compare. You must use words like more, less, greater. Okay, you must use comparative terms, right? Because many students lose marks because you fail to show a good comparison. Okay, you fail to show a good comparison, so you must use all these comparative terms. Now you all know what is superlative terms. Okay, they are related, so it's like most and least, things like that. Okay. Now, and when you write your answers, there's no need to repeat the question. Okay, you can answer directly. Right, I see my students, the question was very long, and you are only given 2 lines. Then the student repeat the whole question just to answer the first part of the question. But there's no need to do that. Just write straight to the point. Okay, so you save some time rewriting the question. Okay. Now, so once you have written all this, then the last part is to make sure, of course, make sure your answers are accurate. So this is to ensure by checking. Okay, so never forget checking. Even for MCQ, like I said, each question is 2 marks. You must check. For open-ended question, very important problem that's a lot of you have. That is using it. This one also eat, that one also eat. Okay, you want to eat your dinner, also eat. Okay, so this eat, try not to use it too often. Okay, especially when the question has more than one thing to talk about. You have object A, you have material B, and then everything is eat and eat and eat. So the examiner will not know which one you are referring to. Okay, so if let's say your English language is not so strong, okay, then avoid using this eat. Just say object A, just say material X, just name it. It's okay. Okay, a few more seconds, but at least there's no confusion. Okay. So these are some general guidelines when you approach your question. Okay, I repeat again, you must analyze the question, think through it, what are the concepts you need, don't jump to conclusion. Once you have all your concepts, you know what the question is asking for, then start to think about how you want to write your answer. Don't just start writing, you must plan your answers. Okay, then finally, always double check. Can we use the word as more often? As you can, but depending on your context. Should we say object X or is X okay? X is okay. So you can exclude the object, the material. If they give you the letter A, B, C, X, Y, Z, P, Q, R, yeah, you can just use those letters. It's okay. Okay, so you save a few seconds. Okay, so CCC framework I've already explained. All right, so make use of find the command word, think about the concept, and try to understand what the question is asking. So what's the context? Okay. So just now, some of you were talking about the command word. Okay, so command words are this. Okay, command words. So there are a number of command words. These are the four most crucial ones, or rather, there's more than four. Okay, these are the four most crucial ones. You'll know what is the first one. Command word is like the instruction in the question. Okay, if the question wants you to give a concise answer without the need to explain, what do you think? How do you think the question will be phrased? Correct. This is state. What about increases? More of you asking, can we say increases? Yeah, sure. But I don't know what you're talking about. Okay. Now give a detailed account in words, but there's no need to explain again. So if there's no need to explain, we just need to describe something. Okay, so this is describe. All right. Now the third one, show how or why by giving reasons. Okay, making some reference if necessary. Okay, so this must be explained. We are trying to explain something that happened. You may or may not use evidence in the question or from the diagram or from the data. Okay. Yeah, state something. They will ask you, state which object is the better conductor of heat, for example. Then you just need to state material object A, for example. Okay. So that's a possible way they can ask. Later I'll show you some examples of how they have asked in the PSLE. Okay, it's just on the next page. Now, the last one, it is used in two main contexts. Either to imply that there is no unique answer or to imply that you are expected to apply your general knowledge to a new situation. Okay, very long description here. But what it means is that when they give you this question, basically, there might not be a one answer. It could be just a suggestion. It could be just a random idea. Okay, or anything that helps in the experiment setup, for example. Okay, so this is suggest. So they can ask you to suggest how to improve the setup. Now, then you look at the whole setup and see what can be done to make it better. Okay, or suggest why something happened. If they ask for suggest, it's most likely something that you kind of have not learned it before. Okay, so they ask you to suggest means you maybe think out of the box. What can you do, okay, to explain something, or what can you do to improve the setup? Okay, so that is this last one. All right. So these are the common words. So we look at, okay, just want to highlight for the first one, usually is state, but there can be a few different ways they ask. Okay, state is like the most common one. They could ask you, so I give you alternatives. So they could ask you to name. Name is pretty straightforward. Just provide the name for whatever thing. Like maybe name a magnetic material. Then your answer must be iron or steel. Okay, so name. Or it could be list. So you come up with a few things. You list out a few things. Okay? So these are possible terms that they can use. I hope all of you are writing this down. All right. Okay. Now, so these are some examples of the PSLE questions. How can you remember the command words? You don't need to remember the command words. You just need to identify these command words in the question. They will give you this question, right? Then you must know what they want you to do. Like if the question asks you to state two forces acting on the object, then you simply just need to write down two forces. You don't have to explain. You don't really need to describe in long sentences. There's no need to suggest anything. So simply write out maybe gravitational force, simply write out frictional force. That's it. State. Okay, if they need to explain, okay, they ask you to explain why the force is gravitational force. Then you explain. So you don't really have to remember this. They will give you the question. They tell you what you need to do. Okay? So these are the different PSLE questions. Okay, these are the different PSLE questions. So let's take a look. Okay, wait Let me look at some of the Q&A first. But you look at these questions. I thought no highlighter usage. Yeah, I did not say highlighter. What? I just say circle and underline. I also don't use highlighter. Is experiment-based question structured question? Okay, no. One of you asked are experiment-based questions structured questions? The answer is no. Okay? Experiment-based questions can be asked in both MCQ and structured questions. Okay? So they can ask you which two setup you want to choose to conduct a fair test. That is already an experiment-based question. Okay? They can ask you what is the hypothesis of the experiment. That is experiment-based question. But they can ask all those in the MCQ. Okay? So it's tested in both MCQ and structured questions. Do we need to link back to the question? One of you is asking. Depend on the question. Okay? If there's something to link back to, then yes. Like if there's some data that you need to refer to, then please use that data and explain the trend or explain whatever is provided there. Okay? So that is when it's usually an explain question. Can you use the word when starting the question? Depending on the context. It is possible to start with when, but I think depending on the context. What is structured question? My friend say is the same as yes. Structured questions are open-ended questions. Okay, you may be familiar with open-ended questions from P3 to P5. Okay, but this year they decided to change the name to structured question in the PSLE exam. PSLE. Yeah, so basically it's the same thing. Okay, so no difference in that. Okay, how can I be specific and not write a very long answer? That's a good question. Okay, clear. Right. Just now, as I said, when you want to write your answer, don't start writing immediately. Think of the answer that you want to write. Then before you even write it down, try to see whether your answer has answered the question. Maybe basically you write it in your head first. Think through it in your head, okay, and see whether your answer is good enough. Okay? So if you think it's too long, then what do you think you should cut down? Okay, what do you think you should cut down? Is all the things that you have written necessary? Okay. Yes, you can write so that we will lose mark for if I give a reason and they do not need the explanation. If you give the explanation and they don't need the explanation, it's fine. It's fine. They will just look at what is necessary. Okay. Okay, let me continue. Okay, so let me continue here. Okay, some of you asking are structured questions difficult? By now you should have tried a number of structured questions. Actually, not all questions are difficult. Okay, the PSLE is not out to kill you. Okay, PSLE is just to assess how much you have learned so far in the last 4 years. Okay, it's not really out there to make it so challenging that you cannot do. Most of the questions I can say you all can do, for sure. There will be one or two questions. They are a bit more challenging. Okay, because there's definitely a need to differentiate whether you get an AL1, AL2, right? Okay, but most of the question you can still be able to do. Okay, right. So no penalization for grammatical error unless the grammar mistake changes the meaning, Alaric. Okay, if the grammar mistake changes the meaning of your answer, then it affects your results. Okay, so I go through some of these. Of course, I'm not going through like how to answer this question. So I'm just showing you examples. These are PSLE questions. So they can ask you to just state two forces. So gravitational force, frictional force, state a difference, state variables. Okay, so simply a short answer will do. Describe can be a longer answer, but you're not trying to explain. Okay, so describe how something happened. Describe how oxygen in the environment reaches the lake. This is a typical PSLE question. Okay, So, we breathe in the air, then the oxygen in the lungs is absorbed into the bloodstream. Okay, then the blood travels to the heart to get pumped to all parts of the body. So you give a full account, like how something happened. That's it. You're describing it, but you're not explaining why this happened. Okay? So explain is when you explain why or even explain how. Basically, they are kind of like the same lah. Explain how basically is to explain how this thing happened, how the mist was formed. This is when you use WCLC, right? Okay, just now I saw some of you asking about acronym. Do you know what is WCLC? You don't understand what's the difference between state and describe. Now you see, right? If I just look at this few example, if I just look at this few example, state two forces. You just need to simply write gravitational force, frictional force. You just state it. Means you just name something. Describe is when you need to write longest a long sentence, a full sentence, basically. Describe. Okay, so you can see, right? Okay, you compare this statement and this question and this question. Say two forces. It's just gravitational force, frictional force. Describe two ways. So you need to write longer and tell me how to separate them. So there's some differences in them. Okay? So explain is just state plus describe. No, no, no. Explain is using scientific concept to explain why something happened. It's not state plus describe. It's not. Explain is to give a reason why this thing happened. Okay? Some of you already asking, okay, so WCLC, what is that? What is WCLC? Surprisingly, many of you do not know what is WCLC. Or maybe you have learned something very close to that. I have students have right, I have students who learn WCC, LCC, or something like that. Very long. No need, just WCLC. This is what we teach in my structure. Okay, so let me elaborate on this brief a bit. So this is for this question. How the mist was formed. Okay, so W for warm water vapor or sometimes the steam. So these are what I call acronym, right? Okay, I mean, to help to remember uh your answer templates. Okay, we'll go through all these answer template again in the last session. C for cooler surface. Okay, the warm water vapor or the steam must come into contact with the cooler surface. And this cooler surface depends on the question. The cooler surface could be a cooler, any random solid surface. It could also be the cooler surrounding air. In this case, for the mist is what is found in the air, right? In the air. Okay, so the cooler surface must be the cooler surrounding air. Okay, so this surface, you have to look at the question. What is it talking about? L for loses heat, and C for condensers. Condenses into water droplets. Okay, I'm sure you should have learned something similar. If you have not, then this is the time. WCCLC, that's some of you have written that. Okay, some of you say you memorize the whole answer template. Okay, if you have already done so, then keep to that. Otherwise, you can try to make use of WCLC or add on so that you don't miss out on all these keywords. Okay, all these are keywords. WCLC, each of them stand for one keyword. Warm water vapor, cooler surface, loose heat, condensers. Basically, they are all keywords that you need in your answer templates. Okay, WCLCW. I think the last W is water droplets, right? So we just put it together. Okay, so use whichever works for you that can help you remember everything. Okay, some of you have extremely long one, WCC, LCW. Wow, so long. Okay, up to you. Okay, as long as you have everything. Okay, I'm going to move on. Okay, let me talk about this AIR answering Framework. Okay, so just now, going back to the top here, when do we use ARR? ARR is an answering framework. So after you have looked through all the questions, you have all your concepts get ready in your head. Then when you want to start writing your answer, think about whether you need to apply the ARR framework or what you learned the CER framework. Okay, see whether it's applicable. All right, so this ARR framework, first part is to provide an answer. Okay, a lot of times the question will be like, or state something, then explain something. Sometimes they just explain. They provide you the answer already. Okay, so AIR is like the full thing, but sometimes you just need to use information and reasoning. Or rather, most of the question you can use information and reasoning. You don't need the answer. Only when the question phrase it like, or state something, then explain your answer. That's when you need the full version, the CER or the AIR. Okay, so if it's just information and reasoning, now then information basically is from the data, from the diagram, what can be used to answer the question. Okay, can you extract some information from the question, from the results? Okay, to support why you choose A as the answer, why you choose material B, why you choose object X, for example. Okay, then you explain. That's the reasoning. All right, so AIR. Okay, you can use whichever framework you have learned, but if you don't have a framework in mind, you can use AIR. Okay, some of you are asking what's the difference between AIR and CER. If you have learned CER, keep to that in school. Okay, if let's say you are not familiar with CER, you can use AIR. They are the same or very similar. Okay, WCLC have not finished. Okay, so some of you still copying. Yes, please go ahead. While I look at some of your question Q&A. Now I have a lot of questions in the Q&A. So like I said, please don't spam me. It's me against a lot of you. I don't. Yeah. So just give me a while. So some of you are asking, spell wrongly, will you get marks deducted? Depending on how bad you spell it. If you have spelled it too badly, you cannot recognize, that is no marks for that. Long answers are not good. Please write more concise answer. Can drawing questions be part of experiment design? It is possible. It is possible that some experiment question can have some drawing, but quite rare. Quite rare. I will not say totally. I will not guarantee there's no. Okay, because nowadays last year PSLE paper, there are a number of 3 marks question to my surprise. Yeah, and there are some drawings. Yeah, so things are changing. There's a change in the trend there. If you write too much, but you miss the point, okay, then you lose. You might not get the mark. Okay, you just need to write concise answers. If your answers have met the point, then you will get the mark. Okay, don't worry. If you think that your answers are really good, then move on to the next one. How, okay, I'm reading this, how your teacher and my teacher never introduced this. Introduce what? The ARR? Okay, if you look at the ARR component in our mind structure material, okay, actually we have actually teach the ARR framework. Okay, so you can ask your teacher about that. All right. Okay, so I will move on. Okay, describing can be relationship question. We talk about relationship next lesson. Okay, structured questions can be easy also. Okay, I have a lot of questions. I cannot answer all. So I'm going to move on. Okay, so we're going to start the experiment-based questions. Okay, so we'll provide you with some answer templates. The very common questions like fair test, relationship, there are some answer template. Okay. Okay, I just saw this question and it's very important. Okay, where did that go? Okay, I just want to clarify one concept that I find very disturbing, and it's a very common misconception. Can you all tell me, is missed water vapor or water droplets? Okay, take your time to write it down. I'm gonna drink my water. Okay, thanks for all your responses. I'm happy, okay, to know that a good 95% of you write water droplets. Okay, so yes, some of you mentioned you saw my McDonald cup. Okay, yeah, that was my dinner. I need to rush to get the McDonald. Okay, so I have energy to teach you guys. Okay, I need the energy, right? So that's where my potential energy come from. Okay, now, so this mist is something that you can see. We can see mist. Water vapor is invisible. Water vapor is invisible. You can't see water vapor. You can't see steam. Okay? Steam and water vapor, they are invisible. You can't see them. The mist that we see, they are all water droplets. Okay? So don't make the mistake. Clouds. You can technically say clouds are mist. Basically, they are collection of water droplets, right? Yes. Michaela, thank you for being so thoughtful to Mr. Chu here. McDonald's is unhealthy, I understand. Um, well, I have it maybe once a month only, or less. Yeah. Thanks for being so concerned. Okay, so let's move on. Okay, so I clarify, is mist are water droplets. Is water vapor and steam in the gaseous form? Yes. Water vapor and steam, they are the gaseous form and we cannot see them. Understand? Okay, so the water in the gaseous form, we can't see. We can only see water in the liquid form and of course in the solid form. Okay, so the mist that we see are water droplets and they are in the liquid form. That is in the air. Okay? Steam we cannot see, Stephanie. Okay, I repeat again. Steam, water vapor, as long as they are in the gaseous state, okay, we can't see. They are invisible. Okay? Okay, yes. Great. You see, I have a few McDonald kaki here. Okay, we all it's a fast food, right? And I was in a rush, so I ate a fast food. Okay. Right. Let's move forward. I apologize again as there are a lot of questions and I'm not able to answer every single one. Okay, so as and when I see it, I try to answer. Okay, yes, you can say tiny water droplets for some of you are asking. Okay, so let's answer this question. We have a few variables. Okay, we have a few variables. Now the first one, can you tell me what that is? It's a variable that is also called independent variable. Some of you might have learned it as independent variable, but I think most of you will have learned changed variable. Okay, so answer is actually inside here. So this is the changed variable. Okay, so this is the variable that is intentionally changed for the experiment. Okay, and there can only be one. You cannot have more than one changed variable in a fair experiment. Okay, it's supposed to be fair. So everything else should be kept constant, and we call those constant variable or controlled variable. Okay, I jump to the third one first. Okay, otherwise called controlled variables. Okay, so most other variables are kept constant. Now, then what is the variable that we measure? I already said the keyword, right? So it's supposed to be the measured variable. Okay, by now you should know all this. Okay, but let's say again, if you do not know all this, it's time for you to, okay, get all this in your head. Okay, so let's try to understand. I repeat again, for a fair experiment, most of your variables are kept constant. You only can change one variable so that you want to see the effect of that variable. Okay, and what you measure as a result, what you measure to get the result, that is called a measured variable. Okay? Yes. Yeah, we are still at McDonald's, clear. Okay, you love McDonald's, yes, but don't eat too much. Like what some of you say is unhealthy. Okay, so eat with moderation, all right? Do not eat it every week. Okay, so these are three variables that you must know. Okay, one quick question. If I draw a graph and I give, like, for example, I give one variable here, variable X. This is, okay, maybe not X, confusing. Variable P, and this is variable Q. Now, just from the axis of the graph, which is the changed variable? Is it the horizontal one or the vertical one? Okay, Q, you can say P or Q. Okay, which is the changed variable? Change variable. Oh, this is bad. This is very, very bad. About 50%, 50-50. That's not good, no? That's not good. Okay, let's clarify this. So I give you one example. Um, okay, so let's say, okay, let me give you some example here. Let's say this is temperature. Okay, and I have volume of water evaporated. Okay, you should know this relationship, right? The higher the temperature, the faster the rate of evaporation. Okay, volume of water evaporated in maybe 1 day. Okay, so you should know this relationship. The higher the temperature, the faster the rate of evaporation. So which means that as temperature increases, there should be more water evaporated in 1 day. Correct? So my graph should look uh something like this. Should look something like this. It should be a upslope. Okay? Correct? So we are changing the temperature. So this is the change variable. I read it as CV. This is the measured variable, volume of water evaporated. All right, so the horizontal axis, the Q, just now was Q. The horizontal axis, the horizontal line here for the ground, that is the changed variable. Okay, so please remember this. I was surprised half of you got it wrong. Okay, for most of the case, or rather 99% of the case, the horizontal axis is the change variable. That's the standard. Okay, yeah, nah? So please remember that. After one After 1 day, in the end, the temperature will be the same as room temperature. No, Justin, we are not talking about living in the air. I'm doing an experiment. If I keep increasing the temperature, it will evaporate faster, right? Okay, so yeah, it's a controlled experiment. Okay, move on. So let's talk about the aim of an experiment. Okay. Now, of course, when we do an experiment, there must be a reason why we do it. What are we trying to find out? So when you all write the aim, I have seen before, students write do, not two. to see if something. Okay, we try to be more scientific. We don't just see. See is not a very scientific word. Okay, we want to find out. When you do an experiment, we want to investigate. We want to find out. So use this phrasing that we recommend to find out something. All right, but we have a few ways to write it. We have a few ways to write it. All right, so this, when you write your aim, it must always have the change and measured variable. Okay, so these are different ways to phrase the answer. And we have a few options. If you see, to find out if or whether, to find out how, to find out which. Many students still do not know the difference between them. Okay, so let me explain here. If in your question, your experiment, you have two setup. One setup, there was something. Let's say, for example, water. One setup, there's water. One setup, there's no water. You want to find out if the presence of water affects the growth of a plant. Because it's either there's water or no water, right? So when we write if, okay, and then our conclusion of this aim of the experiment would be, yes, water affects the growth of a plant. The presence of water affects the growth of the plant. Because if or whether you lead to an answer that says yes or no. That's it. That's the meaning of if. Okay? So your two setup is either there's water or no water. Now, when do you use how? You use how when you have a range of data using the same, let's say, same experiment setup, but instead of two setup with and without water, I have 3 or 4 setups with different amounts of water, 10, 20, 30 ml of water. So with different amount of water, I will see how much my plant has grown in terms of maybe the height or the mass. Okay, so I want to find out how the volume of water affects the growth of a plant. Okay, so in this case, when I use how, my conclusion has changed. It's no longer a yes/no answer. It becomes a relationship. The conclusion becomes a relationship. For example, the more water used, the better the plant grow. Can you see it's different from when it is using if and whether? Okay, so I write it at the side here. Possible conclusion for this. Okay, possible conclusion. We are just finding out yes or no, whether the presence of water affects the growth of a plant. That is for the first one. Second one, possible conclusion. Okay, because conclusions are meant to answer the aim of the experiment. Okay, so it depends on what you really trying to find out. Okay, so you can see a big difference in the conclusion depending on how you phrase the aim of the experiment. Okay? Just want to know how you type so fast. Um, I'm not typing very fast actually. My type rate is quite slow. But you're still young. Of course, next time when you all use your keyboard more often, you'll be faster. Okay. So while you all write all this down, let me look at the Q&A. Wow, I have a lot. Okay, I won't be able to answer all. One of you asking whether it's necessary to put tasks after you give your reason. That is to give a conclusion for your answer. You can, but you don't really have to if the question already has it. Okay? Is describe like relationship kind of. Describe can be used in different ways. You can describe can be used to write relationship question, but describe can be also not for relationship. For example, sorry, I just scroll out a little bit. For example, they ask you to describe how oxygen in the environment reaches the legs. That is not relationship, right? Even though you see, describe how the amount of bacterial M changes with temperature. This is relationship, but again, another example of describe how is not relationship. Okay, so it's not always relationship. So you must be able to tell the difference. WCLC is used for condensation. Some of you are asking what is CER. CER stands for claim, evidence, reasoning. This is what most of you learn in school. Evaporation and boiling, there are a number of differences. Evaporation happens slowly and below the boiling point. Basically, in all temperature except the boiling point. Okay, but boiling occurs only at the boiling point. Okay, so that's one difference. But of course, there are other differences. Boiling is very vigorous. You'll see a lot of bubbling, but evaporation is slow. There's no bubbling. Okay, evaporation only on the surface. That's why evaporation is affected by exposed surface area. But boiling is throughout the liquid. Okay, I already stated three differences there. If I write a 5-line answers when the answer was 2 to 3 lines, I don't lose extra marks. It's okay if your 5 lines answer the question. If they don't answer the question at all, then you don't get the full marks. Okay? Can evaporation occur below 0 degree? As long as it's still a liquid state, yes. As long as it's still a liquid state, yes. Because evaporation is liquid to gas, right? It's a change of state from liquid to gas. So even some substances can exist as liquid below 0. Okay? Remember, there are a lot of things in the world, not just water. Water freezes at 0, melts at 0, but we are not just talking about water. Okay, so any possible thing. So if let's say we're talking about water, yes, evaporation can still occur below 0 degrees Celsius, as long as it's still a liquid state. And water can exist as a liquid state below 0 in some conditions, but that is beyond your syllabus. Okay, so yeah. Okay, some of you are talking about your school teacher say that mist is gas. No, mist is definitely water droplets. Okay, and most students here agree with me. You all keep repeating the questions. Okay, I'm going to skip some of this. Too many for me to remove. Can they ask hypothesis question? Yes, we'll go to that soon. What is smoke made out of? Smoke is made out of dust particles. Okay, nothing related to the water. Are there any other ways to phrase conclusion? Yes, conclusion, there are different ways to phrase them. Because conclusion depends on the aim of the question. So these are just two ways to need to write the aim, and therefore two ways to write the conclusion. Their conclusion can be written in many different ways. Okay? So it really depends on uh the aim of the question. Okay, I'm gonna move on. Sorry for the delay because I have a lot of if you need to go toilet, please go. Okay, no need to ask. We will not have okay, you all need a break. Okay, maybe we can have 3 minutes break. Okay, we just take a pause here. All right, since it's just nice 8:30. So before I move on, we will have a break. All right. So just 3 minutes, come back very quickly. Yeah, I'll just be waiting here. So if you have questions, I'll continue to answer. Okay. We'll talk about hypotheses in a while, maybe. Okay, what are we asking? Okay, let me just reply. C1, C2, C3. C1, C2, C3. Okay, sitting on the chair for 25 hours today. I'll win LeBron James. What do you mean by sitting in a chair for 25 hours? How do you achieve that? Even scientists want to know how I did it. Yeah, definitely. Those that are going to the moon wants to know how you achieve that. Okay, is everybody back? Okay, I'm gonna continue whether you are back or not. So, uh, I was looking at some of your questions. Okay, I just want to answer some of these. So, some of you are asking, will PSLE deduct half mark? I just want to put it clearly here. There's no half mark for PSLE. Okay, no half mark for PSLE. One of you is asking Vi- Vivan. You're asking what's the difference between AIR and C1, C2, C3. I assume that is this triple C, CCC framework. Now, I explain briefly again. So, okay, right, I'll answer that later. Uh, CCC is what we call the analysis framework. That is meant to help you analyze the question. Okay, analyze the question. So you look at the question, see what is the concept the question is about, what the question wants, what's the command word. Command words are these. What did the question ask you to do? Did the question ask you to state, describe, explain, or suggest? Okay, and context is to understand what the question is talking about, and then you try to explain uh the context of the question. So that is triple C, to analyze the question and looking at what the question wants. But AIR is answering framework. meant to help you structure your answer. Okay, so if the question asks you to state something, 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 then explain your answer. Then most likely you have to use AIR. First one answer, you state a short answer. Like for example, they ask you state which object is the best conductor of heat. So you state, okay, object X. That's it. That's the answer. Information you extract from the data. They most likely would give you a graph or otherwise give you a table, give you some information. So you extract the information there. Okay, then you explain why the information tells you that X is the best conductor of heat. Okay, so that is when you use the AIR. Okay, I hope that answers your question, Ivan. Okay, there was this question. Why I never see this question? I know someone was asking about whether boiling they are gaining heat. Why does temperature remain the same during boiling, although the substance is gaining heat? Now, this one is a little bit higher level, but I can explain it briefly. So when water boils, we are constantly heating the water, right? Where did the energy go to? Right. So you all have not learned particles. But to put it simply, the energy is used to convert the liquid particles into gaseous particles. That's it. Okay? That's the simple way of explaining, not very scientific. But to explain it scientifically, the energy is used to overcome attraction between the particles in the liquid to make it a gas particle. Okay? That is the bit more scientific. I hope that clear up the air here. Cannot hear me? Can you hear me? Hello, hello, can you hear me? Okay. Maybe I was sitting a little bit further from my. Okay, sorry. Wait, please answer my question. Is steam a gas or liquid? Steam is a gas. Okay, Steffi, steam is a gas. Okay. I continue, I only have less than an hour. Okay, so let me see how much I'm left. Okay, not a lot, but I have a lot to talk about. Okay, now let's recap what I have just talked about. Okay, so just like I said, for aim, you can phrase it in a few ways to find out if, to find out how. But it's not just these two ways. Okay, just now one of you were asking, can you write to investigate? You can. But investigate is longer. Why I want to write that? Okay, it's the same as, okay, this one, right? The first one, we say that to find out if or to find out whether. Between these two, which one should you write? Which one would I recommend you to write? Of course, write if lah, right? Because only two letter, right? Why write whether when the meaning is the same, right? Just write to find out if the presence of water affects the growth of a plant. That's it. To find out whether the presence of water affects the growth, that's also possible, but write shorter, save time. You don't have so much time in the PSLE. Okay? But either one is fine. So leave it to you. Okay? Uh, Go. I'm looking at your answer. You're missing the phrase lose heat. Otherwise, it's fine. So you need the L. You need the lose heat there. Lose heat, then condense to form water droplets. Okay? Right. Let's move on. So if, how, now the third one is which. Which is not so often. This to find out which, not so often used, but it is still possible. Okay? Basically, you have like a few setups. You just want to find out which object or which material is the best conductor of heat. And then your conclusion is just, oh, material X is the best conductor of heat. That's it. Okay? So I just write here, same thing. Possible conclusion, material X is, okay, maybe not material X. Let's talk in terms of the plant. Uh, tap water is the best for plant growth. Okay, that's it. Okay, so that is when to find out which. And when they use which means that you have a few options, tap water, seawater, pure water. Okay, then you conclude based on your results. Okay, so if we don't write out to find out which, there's also another way, which actually you use if. To find out if the type of water affects the growth of a plant. But when you write it in this way, the answer changes, the conclusion changes. Okay? So the meaning is not exactly the same anymore when you write to find out if, because again, the answer will just be a yes, no answer. So yes, the type of water affects the growth of a plant. Okay? So depend on what is the direction of the experiment. What do they actually want to find out? Okay? Can we use the words interchangeably? Which words are you talking about? What's the difference between evaporation and boiling? Elaine, just now I already verbally explained. I've given three differences. Let me repeat that again, Elaine. Okay, between evaporation and boiling. Evaporation, three things. Occurs slowly, only on the water surface. Okay, and below the boiling points, at any temperature below the boiling points. Three things. Okay, boiling is a vigorous reaction. Boiling occurs throughout the liquid. What's the third one? Throughout the liquid, and boiling only occurs at the boiling points. Okay? Gas to liquid is evaporation. No, gas to liquid is condensation. Cool. Gas to liquid is condensation. Okay? Alright. So let's look at some examples and let's see whether you can get it right. So remember, when you write the aim, you must state either the variables themselves, or if you know the scientific concepts, write down the concepts. For example, we look at this question. Okay, this is a standard photosynthesis, rate of photosynthesis question. And what is being changed here? So during the experiment, we are changing the distance between the torch and water plant. So which is here to here. But let me ask you, when I change the distance between the torch and the water plant, what is the thing that I'm actually changing that affects the rate of photosynthesis? Go, I already answered what? Gas to liquid is condensation. Yes, amount of light intensity. So that is the science keyword, scientific keywords, or what is scientific language. Okay, so that is the light intensity. Okay, I just write light intensity or amount of light. Okay, now volume of gas collected in the inverted test tube. So when we measure this volume of gas collected, what is it used to tell? What is it used to tell? What is it used to tell? When No, I'm not asking for what is the gas. When the volume of gas is higher, what does it tell you? When the volume of gas is lesser, what does it tell you? Correct. Rate of rate of photosynthesis. Now, so these are the scientific keywords that we are looking for, or the scientific concept in a way. All right, so we are trying to find out. Okay, so if we are using the variables in the experiment setup, yes, this is fine. This is how you phrase it. Okay, to find out how the distance between the torch and the water plants affects the volume of gas collected in the inverted test. These are just from the experiment setup. But when we use the science concept, then that is when we use these two terms. Okay, so let's put it in. Right, we want to find out how the light intensity, okay, we can just simply put light intensity. Of course, you can phrase it in different ways. Such as amount of light received by the water plant or light intensity received by the water plant. Okay, but I think light intensity should be fine. Or light intensity received by the water plant. Okay, let me put it more complete. Or amount of light received by the water plant. Okay, how to find out how the light intensity received by the water plant affects the rate of photosynthesis? Okay, so this is how you can answer it in terms of scientific concepts. So it's not just variables from the experiment setup. We can answer in terms of scientific concepts. Okay, please write this down. Go evaporation is liquid to gas, the opposite. Do I need to state what type of potential energy for energy? No, potential energy, just write potential energy. If you draw diagram without ruler, if the lines needs to be straight, then draw with a ruler. Okay? Let's say if you draw the wires for electric circuit, you not necessarily need a ruler. Yeah, you can draw freehand still correct. But best is drawn with ruler, so it's neater. Okay, some of you say that your teacher deduct you half mark. In practice, the teachers in schools they deduct half mark, but in PSLE they don't. It's deduct full mark, 1 mark. Hypothesis, I will talk about it soon. Okay. Okay, all done with this. My science teacher makes me write full. My school teacher doesn't. What do you mean by write full? Write full what? Oh, I see. I see. Oh, you mean for potential energy? Yeah. Uh, for potential energy, naming of the potential energy is not really necessary anymore for the PSLE, but it is still in syllabus. So you must know that there are some differentiation for the potential energy. So it is fine if you write it out. Okay, but even if you don't, it's okay. They do not deduct mark for that. Okay, so it's not necessary to identify the potential energy. Congratulations, Claire. Very good. Yeah, one. Very, very good. Continue to score that kind of grade for WA2, yeah? Good job. No, we can't use them. Justin, we don't use them. That's why I differentiate them here. Okay, that's why I differentiate them here. Okay, so uh there's a reason why we differentiate them, right? Otherwise, there's no need. Okay, so differentiate them. Now, okay, now I see why. Okay, I understand now. There are some of you who are not primary six. Can I just have a show of hand? How many of you are not primary six? I see. Okay, great. That's actually quite a number. Okay, no wonder some of these questions get me a bit confused. Okay, so I will try to answer questions which are more for PSLE, okay? But yes, I try to answer some of your questions because I know you all have not learned some of this. So not to worry. The main thing today is to the main thing today is to learn all these experiment-based questions and their templates. And they are all applicable to all of you. Okay, even at P3 level, you have started to write IM already. Okay, so this is important, huh? All right, so I move on. So let's look at example 2. This one, I want you to tell me the answer. Yeah, we'll talk about control setup next lesson. Or next lesson. I think it's next lesson. Good, thanks for your answers. To find out how the amount of water affects the rate of evaporation, explosive, how the amount of water, Gabriel, are you sure it's the amount of water? Did we change the amount of water? In the question, in the experiment, what we changed is the size of the container. We use the same volume, we pour it into different sized containers. So we are not changing the amount of water. Maybe you want to try again. Hmm. Yes. Perfect. I think, Gabriel, you have corrected answer. Okay, so I think many of you can get this right. Okay, so what we want is this. To find out how the exposed surface area of water affects the rate of evaporation of water. Okay, so most of you can get this. So this is using the scientific concepts. All right. Let me see some of your answers. Okay, exposed surface area, for some of you who do not know, okay, this is learned in P5. So now, even though we change the size of the container, but what really affects how fast the water evaporates will be this. This is what we call the exposed surface area. That's exposed to the air. Okay, like for example, okay, let me just use what you all have in the house, right? Let's say you have laundry, right? How will you fold your clothes? How will you how will you hang your laundry? Of course, you want to make sure your clothes are as exposed as possible so that your clothes dry the fastest. Okay, go understand? So it's the same thing. The more exposed it is of the water, then the faster the water evaporates. Okay, so like for example, out of these four, right? Then this is the one with the largest exposed surface area. So water evaporates the fastest, takes the shortest time. Okay, so when we change the size of the container, we are actually changing exposed surface area of the water, which then affects how fast the water evaporates. Okay. All right. Now, next one. Okay, so after going through all these examples, now it's time to try these questions. Okay, so can you look at question 1? Give question 1A a try. State the likely aim of Carlton's experiment. Okay, let me zoom out a little bit. Some of you cannot see. For the previous question, which answer do we write? You mean for this? You can write either one actually. So if you are not the adventurous one, you can just write the first one. Okay. Second one is also fine. It shows your scientific understanding. Okay, even better. If you know the correct scientific concepts and the correct keywords, yes, then use the second one. But either one is fine. Okay? Yes, I know some of you don't have your worksheet, so this is the question. Do you see the full question? Yes, you see the full question, right? Yeah. Okay, so this is the graph. You must compare the two plants. What has changed? Okay? What has changed? Okay, I'm just looking at the Q&A. I apologize because some of you were saying that your questions are not getting answered. Can you write your question in the chat so that I can see it highlighted? Only important question, please, because I see a lot of random things in the Q&A. Like I'm the top scorer in my class. Okay, very good. Okay, well, okay, I already see a lot of answers in the chat. Okay, so how should you look at this question? So you look at the two. In fact, you must read the question also. They say that he removed the root hairs. So which means that for B, right, no root hair, no root hairs. Okay? And of course, A has root hairs. So when they said no root hairs, basically he removed the root hair. So the thing is, the change variable means that it's either there or not there. So when we write the aim, should we write to find out if, to find out how, or to find out which? Okay, so I saw many answers. I think a lot of you write if, which I think is perfect. If. Okay, so to find out if, right, because the root hairs are there or not there. It's either yes or no, right? So yes, they are there or not there. So to find out if the presence of root hairs affects. Okay, so you see, I have now listed out, I have now named my change variable. This is the change variable. I have used if. Okay, so I want to find out if the change variable affects the measured variable. What is my measured variable? If I just base on the graph here, okay, remember just now I draw the graph, right? And I ask you to identify which is the change variable, which is the measured variable. So the time here is you can say the time here is considered a change variable, but in this case, not really. We're just trying to see as time passes, how did the volume of water left changes, okay? So this volume of water, this is the measured variable. Okay, now, so you can see that the volume of water is a measured variable. So we just put that in our aim, right? To find out if the presence of root hairs affects the volume of water left. Okay, so that is the measured variable. Okay, this is one possible answer. There can be different answers, okay? But this is just one. Okay. Xing Yu, correct? Now I just saw your question. We should write, your teacher said that we should write example as the temperature increases, the amount of oxygen bubbles produced decreases for relationship. Yes, that is for relationship question. Yeah, that's for relationship question. But I'll talk about relationship in the next lesson, not today. Okay, but yes, that's one way to write the relationship answers. Have I answered your question? Okay, so looking at some of your answers, S also can. Since you can use S as the, what is that again? What are the two variables that you have? Uh, as the temperature increases, yeah, you can use S, correct. Or you can use when temperature increases, or when temperature increases, number of bubbles produced increases, also can. Okay, so relationship, there are a few ways to phrase them. As long as your trend is correct, it's fine. Okay? Yeah, as long as the trend is correct, it's fine. Okay, so some of you are asking, yes, affects the amount of water taken in by the plant. Also can. Yes, also can. So instead of the volume of water left, which is in the graph here, some of you have written that to find out if the presence of root hairs affects the rate of water absorbed by rate of absorption of water by the plant, also can, or amount of water absorbed by the plant, also can. Okay? Yes, that's another way to write it. Yeah, I think a lot of your answers are the same as mine. Okay? Amount of water taken by the plant, yes, amount of water taken by the plant is fine. Amount of water. You are saying that you write amount instead of volume. That's okay for PSLE. Yes. Volume is clearer. Volume is more specific. Number of root hairs. Now, not number. Root hairs, you can't really count root hairs. Sometimes they're very small and yeah, so just not number. Okay, because why? One thing is the question says that he removed the root hairs. So when he did not add on anything, means that it's totally removed. There's no more root hair. So it's not about a number. Okay, so it's there or not there. So the presence of root hairs. Okay, not number. Yes, presence. Yeah. Okay. Now let's move on to B. State which line M or N represents the volume of water left in setup A. Some of you have already written the answer. Very good. Okay. So which one represents the water left in setup A? Now A is the one with the root hairs. So with root hairs, you should expect that the plant is able to absorb water faster. Okay. Right. So you see, right? I have looked at the question, I have analyzed, I have looked at the context of the question. What is the common word here? Can you tell me the common word in this question? Okay, so we go through the CCC framework. So I look at the common word, state, explain. So whenever I state and explain, okay, this is one time I can use AIR or CER if you want. Okay. Then I look at this topic. Okay, so I already know, right? Based on the previous part, I already know this is rate of absorption of water by the plant. Okay. So I already went through go through the question, so I know the context. So let's answer the question. Which line? So for the answer itself, simply put line N or M. Okay, so one of it. So line N. Okay, line N or N itself is fine. So what's I? I is information or evidence for E. Okay, I is information. Why did we choose line N? What information in this question make us choose line N? So we are looking at this. We are looking at this. Why did we choose line N? Because volume of water left decreased faster. Okay. So we choose line N because volume of water left decreased faster. Okay, I write the full one here. Okay, that is from my data. Okay, so you give me evidence from the graph, from the table. That is your evidence or the information. Okay, then last one, reasoning. So what if, so now I said that line N shows that the volume of water decreases faster. So what? What does it tell me? Okay, so it tells, so we need to explain, right? So why did it decrease faster? All right, so based on what we know in setup A, the plant has root hair, right? Okay, so the plant has root hair, so it will absorb water. The plant in itself A has root hairs, so it absorb water faster than the plant in B without root hair. Okay, the answer is a bit lengthy here. That's why we have 4 lines. Okay, but of course you can write it in different ways and still achieve the same answer, still get the same 2 marks. Okay. Now the just writing information here from the data gives you the first mark. Writing line A is not going to get you the first mark. Sorry, line N. Choosing M or N is not going to get you your first mark because anyone can just guess it's M or N. So there's no marks to that, but you must still get it right, of course. Okay, but being able to extract information from the graph, that gives you the full mark, the 1 mark. Okay, then the second mark is the explanation. It decreases faster because the plant had root hairs, which helps to absorb the water as compared to the plant in B without the root hair. Okay. Ili, you need to include the data, information from the data from the graph. Okay, why you choose line N? Because it decreases faster. And then you talk about the hair. Because the plant has root hair, they help to absorb the water. Okay, so compare it to the plant in B. Okay, so like what you said, you are not likely to get the marks, yeah. So you need to be more specific on that. If you write our answers like how you wrote it for this answer, yeah, of course, if you write your answers like mine, you should get a mark lah. Yes. No, okay, some of you still asking about the potential energy. Potential energy don't need to specify, okay? No need to specify. How many marks for PSLE? 100 marks. PSLE 1 hour 45 minutes. For circuits, you can draw freehand, but if you want to be neat, please use a ruler, okay? Freehand is fine, but draw neatly, not just scribble everywhere. No, PSLE is 1 hour 45 minutes only, not 55 minutes. The class ends at 9:30. Cell parts no need, okay? Cells no longer tested for PSLE. PSLE is not very hard, provided you have gone through practice, okay? Not going to the PSLE with nothing. Okay, all done. Okay, I know a lot of you have a lot of burning questions that you all like to ask, and I am not able to answer every single one because I'm one teacher against a few hundreds of you. Okay, so you can see, I'm definitely not able to answer everyone. I can barely see all your questions. There are just too many. Okay, so what I'm gonna do, okay, to help those that really have burning question. I know I cannot answer everyone. Hold on, let me get. Hold on, Okay, I know all of you have a lot of questions. Okay. By the end of today's lesson, if you really need to ask a particular science question, okay, please email me, ask the MyStructure Science team at this email, okay, feedback.primary-science@mystructure.com. Okay. I know I am going to miss a lot of questions. I'm surely going to miss most of your questions because it's just me and I still need to teach. I cannot answer all your questions, okay? So please email us. Okay, if you don't have an email, ask your parent to help send an email. All right. I'll try to answer all of you as soon as I can. All right. But I will still continue to answer here. Okay. So I have one last part to go through. Okay, before we end at 9:30. If you write a letter in a word wrong, do I have to cancel the whole word? If you want, you can, or you just cancel that and write a letter above. Okay. Oh yeah. Thanks, Roy. Yeah, so this is the email in the chat, feedback dot primary dash science and mystretcher.com. Yeah, I sent it to the host instead just now. Okay, what is the difference between melting point and freezing point? Melting point is the temperature when a substance melts. Freezing point is the temperature when a substance freezes. But if you talk about the same substance, then the freezing point and melting point are the same. Okay? It's like water melts and freeze at zero. Okay? Okay, now let me talk about the one last part. Okay, I still have people asking me to answer question. Continue to paste your question and I try to answer. Okay. I will stay back a short while only. Later after 9:30, I'll stay back a short while only to answer the last few burning questions that all of you have. Okay, like I said, I try my best, but you all must be patient with me, okay? Cannot be angry or anything because I'm trying. All right. Okay. Now, let me finish up first in the last 15 minutes. So hypothesis, just now some of you were asking about hypothesis. Okay. So let's talk about hypothesis. Now, a hypothesis is a statement that can be tested by an experiment. What do I mean by that? Meaning that it's just a hypothesis is like I just say something and then I go and do an experiment to test whether what I'm saying is correct. Okay? I give a classic example. I always use this example to explain to my students. Okay, let's say for example, okay, I don't know how many of you have cats at home or animals at home. So let's say I have a cat, I let it roam outside, okay, and my hypothesis is that okay, my cat knows how to come home on its own. That is my claim, my hypothesis. Okay, I'm guessing that okay that my cat knows how to come home on its own. That's my hypothesis. So what I'm going to do next is I'm going to conduct an experiment. And the aim of the experiment is to find out if my cat knows how to come home on its own. Okay, I'm going to write this down so it's clearer for everyone. Okay, so hypothesis, for example, this is just an example. I don't have a cat at home. My cat knows how to come home on its own. Okay, my aim of the experiment. So once I have my claim, once I have my hypothesis, okay, then I can come up with the aim of my experiment. What do I want to find out in my experiment? To find out if my cat knows how to come home on its own. Okay, so it's either yes or no for the conclusion. Okay, so conclusion, yes. Okay, no. I can say yes, I can say no. My cat knows or does not know how to. Basically, it's just repeating, okay? But you see how I phrase it, the meaning is not the same. Okay? So you can see hypothesis is a guess. I do not know whether my hypothesis is true or not. Then that is when I will conduct the experiment to find out. So I'm guessing it. So it could also be the same as my conclusion. My hypothesis could be the same as my conclusion, provided my experiment results tally with my hypothesis. All right. So you can say that hypothesis is a guess of the results. It's a guess or prediction on the result of the experiment. But essentially, the true meaning of hypothesis is a statement given which is then tested with an experiment. Okay, like in this case, I'm just guessing that my cat can come back on its own. So I will go and conduct my experiment to find out whether that is true. Okay, so that is hypothesis. And this hypothesis can take the form of a relationship question, in the form of relationship. Like for example, uh, the higher the temperature of water, the higher the rate of evaporation. Of course, this is a relationship that you already know. There's a scientific concept that is in your syllabus. But let's say I give you something else that you will not know. Like for example, um, the darker the darker the surface of the container, the faster the water in the container evaporates. That is my hypothesis in the form of a relationship. So, is the water going to evaporate faster in the darker container? That's when I go and conduct an experiment. Okay, I'll conduct an experiment to find out whether that is true or not true. Okay, so usually they will test your hypothesis on things that you have not really learned before, but it's still within your syllabus because hypothesis is just a guess. You can guess it right, you can guess it wrong. It's okay. Okay, so if you write a hypothesis that is an incorrect hypothesis, it is still marked as correct. Okay, so you go through some examples so better understand that. All right. So we look at example question 2 here. So Peter wanted to find out how temperature affects the movement of colored water up a strip of material X. Okay, so what we have here, this is the aim, right? To find out how temperature affects the movement of colored water up material X. This is the aim. The aim usually comes after the hypothesis. So what do you think is the hypothesis? Okay, we continue reading first. He used three identical strips of material X. So three same strip of material X, three beakers with equal volume of blue color water. Basically, everything else is the same. What is the change variable? Temperature, right? Okay, that your variables are all in your aim. This is the change variable. Movement up the strip is the measured variable. How fast it moves up or the distance it moves up. Okay, so what could be my hypothesis? So to come up with this aim, I could be writing a hypothesis. You can take it as I'm guessing the result. So let's say if I'm guessing the result, how would you write the hypothesis here? Okay, very good, Gabriel. The higher the temperature, the faster the movement of colored water. Actually, that is correct already, Gabriel. Okay, and Xavier as well, same thing. Okay, very good. So some of you already have the perfect answer for this. So this is the answer. The higher the temperature, the faster the movement of colored water up the strip of material X. But is this the only answer? No. Remember, hypothesis is just a guess. I can write the wrong one. Like for example, I could write the lower the temperature, the faster the movement of colored water up the strip. Do I still get 1 mark for this? Yes. Because again, hypothesis is a guess. And it's okay to make a wrong guess. You just have to use the correct variables in your answer. But of course, if it's a hypothesis where you know the relationship, then write the correct one. Okay? There can be wrong answers for hypothesis. There can be. If your answer is totally not related to the aim of the experiment, I can write a totally random one, and of course that is wrong. Okay? Now, state the variable he changed in his experiment. So what did he change? Yes. So I have already identified the change variable. So it's the temperature of the water or the blue colored water. This one is, I have given the answer for this. Suggest what he should measure to obtain the result. So I've already identified the measured variable, but the measured variable written here is just on movement of colored water up the street. Just now, but actually I've already mentioned a few. Okay, so what do I measure? I could measure a few things in the experiment. Maybe the time taken, maybe how far it has traveled. Okay, height of the water on the strip. Okay, height of the water on the strip. Uh, you likely need to give a time range. Okay, you need to give a time range. Length of the stain of the blue colored water. Give it a time range, like maybe a minute. Okay, so you talk about the length of the colored water on the strip, but you should give a time range because if you just leave it there, the whole thing is going to be stained. Okay, so there's no point in that. Okay, not this. Okay, so that is one. You could also measure the time taken for the water to move to the top of the strip. That will tell you the movement, right? If it takes a shorter time, it moves very fast. If it takes a longer time, it moves slowly. Okay, so two answers to this. Does wind affect evaporation? Yes, of course. Okay, quickly copy this down. So remember, what matters here is not truly the answer of the question, but being able to understand what hypothesis is, how to write your aim of the experiments, how to write the hypothesis, how to write some of this conclusion, suggest, right? You see, this is the command word here. Understand what these command words are. Okay, I'm going through what we have just learned today. Command words state, suggest. So again, you see, suggest what he should measure. So you could give a possible answer. That is what suggest is about. Okay, cells will be removed from the PSLE. Cannot hear me. Can hear me, Chloe? Not sure, is it my mic? Let me see. Think I was sitting slightly further. Okay. Yeah. So I was talking about the things that we learned today, right? Aim, hypothesis, all the answer template, analysis framework, answer framework. Okay. All these must go and practice again. Okay. Okay. I have one last question. Are there questions that you can write? For example, object A does not affect the rate of photosynthesis. Yes. Hypothesis, yes. So one of you is saying that, okay, for hypothesis, can you write like temperature does not affect the movement of the colored water up the stream? Totally. Yes, another possible answer. So thanks for that, Rufstra, if I pronounce correctly. You can write that temperature does not affect the movement of the colored water up the stream. That is another hypothesis. That's why we will do this experiment to find out whether it affects or not. Okay, so another possible answer. Yes. Okay, last one with a few parts, two parts. Okay, so again, testing you on hypothesis and the aim. Okay, B trying to find out this is the aim. Now, what is being changed here? Okay, there are a few ways to say what is being changed, but the most obvious one is the distance between the seeds, right? Whether they are all together very close or whether they are further away from each other. Okay, so maybe let's say the change variable is distance between seeds. Okay, the number of seeds are the same. So the only change variable is the distance between the seeds. And of course, if we are talking about seeds, and then of course we are looking at whether they have germinated or not. Okay, so number of seeds that germinated, that is the measured variable. Or you can simply say the germination of seeds. Okay? Now, so the hypothesis here, I've changed the distance between the seeds. So what could be a possible hypothesis? Our measured variable is the germination of the seeds. Alright, so you can think in terms of, like I said just now, maybe let's write this. Okay, just now I was saying that temperature does not affect the water up the strip, right? So maybe let's write this. Distance between the seeds does not affect the germination of seeds. Exactly like what I mentioned just now. Okay, so this is a good example. But of course, this is not the only answer. Okay, some of you have written, okay, the greater the distance between the seeds, the faster the seeds germinate. Okay, it's not. Okay, so I see a wrong answer here, Kaitlin. The faster the seeds germinate, I think that's not what they are looking for. They are looking for, okay, the faster the seeds germinate. Uh, okay, I think that can still be fine. That can still be accepted because they say after 2 days, number of seeds germinated. So, yeah, I think that's okay. Never mind. Kaitlin, yours is fine. Okay, so you can talk about how fast the seeds germinate or the number of seeds germinated after 2 days because all have some time as part of the factor, so that's okay. Yeah. So my answer here is just one of the answer. Okay, of course, like I said, you can write greater distance, greater the greater the germination of seeds. I think greater that would be wrong because what does it mean by greater germination of seeds? Okay, so you can say more seeds germinated, or you can say the seeds germinated faster. Okay, faster. So not greater. There's nothing greater for that. Okay. Now, so what was she trying to find out? Okay, so again, the aim is something that will answer. The aim is something that we come up with when we have the hypothesis. So we talk about the distance, we talk about the germination of seeds. So we want to find out if the distance between the seeds, I have already written out the measured variable and change variable, right? So all this you put inside your aim. Okay, follow the template that we have taught you today to find out if. Okay, so here we use if because I have only two setup. One, they are very close together. Second, they are far apart from each other. So I want to find out if the distance affect. This is possible. In fact, for this question, if you write how, it's fine. I think I can change the distances between them. So this is okay. But I will better accept if. Okay, so if is accepted, if you write how, it can also be accepted in this case, but not all the time. Okay? If you write to find out if the distance between the seeds affects the number of seeds that germinated, also can. Okay, basically right from here, directly from the question itself. That's fine. I have changed it here to the germination of the seeds, but essentially it means the same thing. Okay? To find out if overcrowding of seeds affect the seeds that germinated, yes, that is correct also. Yep, Kaylin, that's fine. Jela, that's also okay. Yes. Okay. All right. It's 9:30. I have reached the last page already. Now, next week onwards, we'll continue with a relationship and so on. All right. So, do remember to register for that session as well. You need to register for all the sessions. So, session 2 and session 3, you can register them. Aim has hypothesis has the similar answer to aim. Not really. Not really. They are not really they are similar, but not the same. Okay, because remember, hypothesis is what you claim. Okay, then from the hypothesis, you want to do an experiment. So your aim must be closely related to your hypothesis. Okay? Okay, I teach at West Campus in Clementi. That's my only lesson there. Uh, just now I sent the feedback link. Okay, let me find my email again. So for those, again, I say, if you have a burning question after today's session, this is not the last session. There's still session 2 and session 3. But let's say after today's session, you really want to ask question, okay? Send an email to us, okay? The My Strategy Science team. And if you do not have an email, you can ask your parents to help you send, right? Or you can create an email. Yeah. Okay. Right. So for those who have no further questions, yeah. For those with no further questions, you all may leave already. I'll see you guys next week. Thanks for joining us today. All right. Have a good rest. Thank you so much. Thank you and bye bye.